Now we're on exercise 2, which is using some more advanced feature of ASTRA-sim. You can easily change communication size, and you can run multiple runs simultaneously. And using this feature, I want to run several other all-reduced collectives and compare those results. So now let's assume last time we just run 1 megabyte all-reduce. Now let's assume we want to run 5 megabyte all-reduce. One trivial way is, of course, you can go into the workload file, change the size to 5 megabyte and run it. But what if we want to run like 10 megabyte or like 15 megabyte, 20 megabyte all reduce? Each time it's very hard to just go inside and change the file number. So that's why ASTRA-sim offers you this input feature, like communication scale. Instead of going and changing the input, like workload input file, you can just leave there 1 megabyte and set this communication scale to 5. This will automatically scale the communication size 5x. So this is effectively running like 5 megabyte all reduce without changing any file. And there's some time you want to run multiple configurations and store all the results in a single file. To do that, we offer those two input things, like total stat rows and stat row features. Total stat row, you should specify how many runs you want to run. So here, like, let's imagine I want to run 1, 5, and 10 megabyte all reduce and store it into one single result file. We have total 3 communication like configuration. That's why I set this total stat rows to 3. And each run, I give them the index, basically ID, like starting from 0. That's why each configuration has stat row 0, 1, 2. And because I want to test 1, 5, and 10 megabyte all reduced, just as I did before, I don't change any file. I just changed the communication scale to 1, 5, and 10. This, when I run those 3 configurations, they will basically run 1, 5, 10 megabyte all reduce and store it in a single result CSV file. So we can go extreme, like let's say we want to test all reduce size from 1 megabyte up to 1 gigabyte. It has like total 11 configuration. What we can do is here I just created some like simple for loop in the script. And as you can see, total stat row, we have like 11 total configuration, and the index, I just give the ID, and I'm just changing the communication size as needed. So this exercise is like, let's do this. We can go to exercise 2 folder, build ASTRA-sim again, which now runs very fast because we are not changing ASTRA-sim in any way. Then exercise 2-1, you can run this. And this is running that configuration. All reduce on the same topology, 8 size ring from 1 to up to 1 gigabyte. And as you can see, if we go to the exercise 2 result 1 folder, here, one single tutorial result will hold all the 11 configurations results. And let me just go back to the slides. And I'm just summarizing it here. This is the tutorial results CSV folder. Again, we're just testing all reduced. That's why we don't see any compute time, and every like period time is just fully exposed. And as we're increasing the all reduced size per each MPU, the total communication size is increasing. And when I plot this collective running time versus all reduced size, is linear. So those kind of experiments are possible using those input features of ASTRA-sim, even without changing any input file. Now, as I mentioned before, analytical backend, one huge benefit is we can just test like arbitrary topologies very easily. So here we have, instead of ring, we also have 2 other components, switch and fully connected topology. And then as you can observe here, switch topology, the best algorithm you can run on it without any congestion is halving doubling all reduce algorithm. And each MPU just has 1 link connecting it to the switch. Whereas the fully connected topology, the best algorithm on it is direct all reduce, not halving doubling. And because it's fully connected, every NPU has n-1 links connecting it to the neighboring NPUs. So I can go and change the network file, create like switch.json and like fully connected.json file. It's still one dimensional topology, but now it's not ring, it's switch and fully connected. I'm still testing 8 GPU system. I just changed links count. I mean, switch only has 1 link connecting it to the switch, whereas the fully connected, it has 7 links connecting it to other MPUs. And link latency and bandwidth, I just lived at 500 nanoseconds and 50 gigabytes per second. So I gave this, I again already pre-populated this input files for your convenience. And accordingly, I changed the system input file. Here, the change is instead of ring all reduce algorithm for switch, I'm using halving doubling algorithm because it's topology reflective of switch topology. And fully connected, for fully connected topology, I created the direct, like a system input file using the direct all reduce. Then as always, I want to test the experimental setup is I want to test 1 gigabyte all reduce on 3 different topologies and compare them, ring, switch, and fully connected. Here, that's why I set the stat, like total stat rows to 3, and I just call switch. I just run this binary 3 times with switch algorithm, switch topology and algorithm, and fully connected, which is already pre-populated and written in exercise 2-2.shell script. So let me just go back, build again, and run exercise 2-2. It runs 3 topologies. Ring, switch, and fully connected. And again, if you see, go back and see the result folder. Here it generated result 2. And in tutorial results, they reported 3 configurations, ring, switch, and fully connected. And the total time taken, total communication time taken to run 1 gigabyte all reduce. As you can see, switch is the slowest, then ring, then fully connected. Because if you see the topology file, we left the link latency and bandwidth the same as all 50 gigabytes per second. Yet this fully connected topology just has more physical links, 7, whereas the switch one has just 1 link. That's why fully connected was able to become the fastest topology. But it's costly, so that we should take into consideration. So by using those more advanced input features like communication scale, total stat row, like we can run multiple ASTRA-sim at a single time and dump every result in a single CSV file, even without changing any like workflow size or whatnot.